Single case experimental design is different from the experimental design that we looked at in that it relies on very small number of participants, one or two, and still this is an experiment, therefore independent variable is manipulated. Why should one be interested in this design? Because this has a lot of clinical application, such as how a particular patient responds to a specific technique of therapy or treatment, or are interested in special population, such as children with learning disability. So the key in single case experimental design is less emphasis on statistical power, but more emphasis on the quality and frequency of the observation uh, obtained from a single participant. Basic single case experimental design is a comparison design. So as you can see in this graph, so this has a 5 times of observation under the baseline condition. Base 1, base 2, base 3, 4, 5. And then in the treatment, some different kinds of or specific kinds of treatment is introduced. The difference between the baseline and treatment is an independent value. And then you continue the observation to see whether or not there is a different performance or different kinds of behavior emerges as a result of the introduction of the treatment. So the concern is even if you observe the difference between the baseline condition and treatment condition, as you can see in this particular graph, can you be really sure that's due to treatment condition? Or are there any other possible confounding here? That's the question that you need to think about. One weakness or limitation of comparison design is uh, we cannot be sure that the difference that we observed in the behavior as a result of the manipulation of the treatment, that means transition from baseline to treatment condition, may not be exclusively attributed to the introduction of treatment, because people or animals' behavior may naturally change as a function of that, like growth, development, getting used to. So that gives us a concern that the comparison design doesn't not have high levels of internal validity. The results may not be due to the treatment. So that's why we think about alternative design to improve the design. So that's the ABA reversal design. So the reasoning here, rationale here is if you can reverse the treatment by uh, uh, reversing or withdrawing the treatment, and if you can bring back the performance or behavior into the baseline, then it increases the chance that the behavioral change observed as a function of introduction of treatment is due to treatment, not due to other confounding variable. So as you can see in the graph, uh, up to baseline 5, and then the treatment, the performance remains somewhat similar. But then, as a result of introduction of the treatment, the performance level increased. And then, once you reverse the treatment and bring it back to the baseline, the performance goes back to basically similar to the first baseline level performance. This means treatment can be reversible by withdrawing the treatment. So this means the effect that you observed during the treatment is very likely to be due to treatment, not as a due to development or practice or any other effect. So what is the concern? However, there is a concern that with the ABA reversal design, which we need to talk about, we will talk about in the next slide. One critical concern or limitation of ABA reversal design is its assumption that uh, in order for the treatment to be observed effect to be due to treatment, the treatment effect need to be reversible. This means if you withdraw or reverse the treatment, the effect of the treatment should disappear. But this is somewhat unreasonable assumption for multiple reasons. Number one, effective treatment could be nearly permanent, such as you quit smoking as a result of some treatment condition. Even if you reverse the treatment, it's actually good that you don't smoke. That doesn't mean the treatment didn't work. It's just the treatment may be near perfect or near permanent. Okay? The other possibility is it may sometimes be unethical to try to reverse the effect, even if it's possible to reverse it. So one approach to address the limitation of ABA reversal design is a multiple baseline condition experiment. So you have a multiple research participants, and they are going to experience baseline and treatment condition at the different timeline. So therefore, participants 1 starts baseline, and baseline is going to continue like 10 times, followed by treatment. But then the other participants 2 is going to have only baseline observation for 5 times, and then the treatment is introduced afterwards. So this is going to be beneficial because if the possibility that the effect observed, the effect is due to some developmental effects such as maturation, uh, having the treatment condition introduced at the different stages should address this concern. Because then, if the maturation is the cause of the observed effect, then we shouldn't observe the effective treatment corresponding to different time in which the treatment is introduced. So here is an example of multiple baseline condition. So it's across subjects. So the first subject, baseline 5 times, and then in the 6th time, treatment is introduced. But for the second subject, the baseline continues until 8, and the treatment is introduced at 9th. And then clearly the effect of the treatment happening at the different times. And if the effect of treatment is due to maturation, this kind of observation shouldn't happen. Moving on to the discussion on quasi-experimental design. So what is quasi-experimental design? Quasi-experimental design has manipulation of independent variable and also measurement of the effect of independent variable using a or multiple dependent variable. So it's very similar to experiment. However, in quasi-experimental design, there is a reason to believe there is only a weak or some absence of the complete or maximum control of the extraneous variable. For example, let's say that you are exploring whether or not giving a particular study guide improves students' comprehension of materials. Okay, but it's almost impractical and unethical to divide one class randomly into a study guide group and non-study guide group. And even if I do that, probably students within the classroom is going to talk about the study guide. Therefore, it's not practical to do an experiment, true experiment, using random assignment. Instead, what I could possibly do is to find two sections of the same course, like statistics taught in the morning, statistics taught in the evening or like afternoon. Then I'm going to use the existing class to be different groups, and one as a control group, and the other one is an experimental group. So in that case, the control is weak because there is a likelihood that different groups of students are in the class. But nonetheless, it's better than not doing an experiment or trying to do an experiment by randomly assigning the condition within the class, which may anyway compromise the experimental control. So that is the quasi-experimental design. So there are many different kinds of quasi-experimental studies, and some quasi-experimental studies are much more reliable or clear in conclusive in interpreting its finding. So we need to talk about the different kinds of quasi-experimental study. The simplest and the most not reliable, trustworthy, untrustworthy quasi-experimental study is one group post-test only design. So the participants receive some manipulation, like let's say providing a study guide, and then their performance is measured after this manipulation of study guide. And let's say, so you give a study guide to all the students in the class and monitor how well they perform on the exam. And because the most students obtain a passing grade, you start believing that the study guide work. This is not a valid conclusion because there is no comparison. It may be completely accidental. This group of participants are very hard workers and have high academic ability. So therefore, you cannot conclude based on this study that study guide worked. So you need some comparison or control condition. To improve the design, now you're going to have a pretest before the manipulation. And then after the manipulation, you're going to administer the post-test. So it's a pre-test, post-test design. So then the post-test performance is better than the pre-test. You conclude manipulation, which is providing the study guide, improve the student's performance. This is better than the last study because you have a comparison between post-test to pre-test. However, this improvement of post-test performance over the pre-test could be due to the repeated exposure of the same concept or idea, not due to basically having the study guide available. Limitation of the previous design, which is one group pre-test, post-test design, is the limitation due to order effect. Like the measurement opportunity for the pre-test is going to influence the measurement of the post-test. And in addition, there may be the position effect where the people's performance may naturally improve or decline due to fatigue or the practice effect. Okay, so now in order to remove the types of order effect or situational factors, you may switch to the manipulation of independent variable as between subject assignment. So here, non-equivalent control group design, you are going to select two groups of participants, such as the section 1 and section 2, and then you are going to manipulate the independent variable assigned to naturally occurring grouping, such as section 1 and section 2 classes. So the manipulation study guide is given to class number 1, and the control condition is assigned to class number 2. And however, the problem is there may be naturally existing difference between these two different groups of people. That's why, again, this is not the perfect control, and it undermines the internal validity.
So the final design of the quasi-experimental design is called non-equivalent control group pre and post-test design. Okay. This is as close as it gets to actual experimental design. Okay. So how it's done is, first, you're going to have two groups of people, and two groups of people are first pre-tested, and then after the pre-test, they are going to experience some sort of manipulation. One group of the people is going to go experience the control condition, the other group of people is going to experience the manipulation. So the difference between these two groups are the independent variable. And after these, the people are going to be post-tested. Therefore, you compare the pre-test and post-test performance across these two groups. And what we expect is, if there is an effect of the manipulation, you are going to observe the changes in behavioral performance for the group B, which has the manipulation, but not in the group A, which doesn't go through the manipulation. For example, in this particular case, the no study guide condition, their performance may improve a little bit, but there shouldn't be that much improvement. But on the other hand, for the condition B, the study guide group, their improvement from the pre-test to the post-test should be larger compared to the control group. Okay, so the difference between this design to experimental design is this group is not completely equivalent, because the reason is you don't have the random assignment.
Right.
That's why this is still the quasi-experimental design. But still, even though these groups are not completely equivalent due to lack of random assignment, it still gets pretty close to experimental design, because these people are both pre-tested and post-tested. Therefore, a fairly detailed analysis is possible to have very constrained interpretation of the results.
Right.
Okay. So the next slide is going to show the patterns of the possible results that you obtain in this design, and we discuss for each different patterns of the results what is the possible interpretation. Okay. So non-equivalent control group pre-test post-test design, which is one of the quasi-experimental design study, can produce following kinds of data. The data that's actually presented on this slide as A, B, and C, and D. So let's look at this data, the figure. Okay. So in this case, the x-axis is pre-test versus post-test, and then the two different kinds of plot are two different kinds of conditions. And then the y-axis is the difference in performance. So you can imagine that this provides, for example, the pre-test and post-test for study guide, introduction of the study guide. And then one of the conditions is the study guide condition is in solid line, no study guide condition is in a broken line or dotted line, and then the y-axis is the actual performance on the test. And the interpretation of these four different kinds of patterns of data are provided in the next slide.
So this slide summarizes the conclusion that you can potentially discern based on four different kinds of graphs presented in the previous slide. So please read this carefully. Point so far, okay, by studying quasi-experimental design. Even though many people or some people believe the results of quasi-experimental studies are valid in making causal conclusion, that's actually incorrect, because there is no perfect experimental control. Internal validity is somewhat compromised, but the extent to which the internal validity is compromised is dependent on specific quasi-experimental studies. Some quasi-experimental studies better than other kinds of quasi-experimental study. Number three, even though none of the quasi-experimental designs are 100% perfect, one sometimes needs to use quasi-experimental design in certain cases, such as the applied studies experiment, trying to figure out whether or not particular intervention work in the classroom, educational setting. And so therefore, it's better for you to understand strengths and weakness of different kinds of quasi-experimental design. Several slides, we talk about developmental research design. So the developmental research designs are interested in how people's psychological properties or features or tendency changes. For example, how people's preference for music, food, clothing changes. How people's problem-solving ability changes. How people's politics, religious belief changes across a lifespan. One of the methods of developmental research uses cross-sectional method. Definition of cross-sectional method is you are going to recruit multiple group of people with a different age. and they are studied at only one point in time. So you're going to have 20 years old, 10 year old, 15 year old, right? And then you look at basically how uh, the responses or some psychological properties such as preference for food, etc., are different across different age groups. And then based on that, you're going to infer the difference that you observe across different age groups, like 5 to 10 to 15, are due to development. So here is a program. Even though you are making inferences that the difference in the, for example, food preferences due to age is due to development, it's possible this is based on some other things. For example, something called cohort effect that we talk about later on. That is, these people, 5-year-old, 10-year-old, 15-year-olds are different cohort belonging to different time in the history. Cohort effect associated with cross-sectional study is more fully discussed. So the problem with cross-sectional study is the fact that people with a different age are different not just in terms of age, but the time in which they are growing up or they are spending their time in their life. Okay, so that produces they are actually therefore they are understood to belong to different cohort. And for example, the children and adolescents' preference of food may be mostly due to cultural phenomenon. If you get exposure to fast food, they may like fast food, whereas the people who don't get exposed to the fast food, they may not develop the taste for fast food. So let's say that you observe, whereas the younger people prefer fast food and older people do not prefer fast food. That may be due to not the developmental difference, but due to cohort effect. Longitudinal method of developmental study is different from cross-sectional study in that the same group of people are observed at different times in longitudinal study. So you follow the people to observe at the different age group, different time in their life. Like 5-year-old when they observe, they follow it to 8-year-old, then 12, and so on. Okay. So one question is how cohort effect affects longitudinal method. So as we already talked about in cross-sectional study, cohort effect compromises internal validity of cross-sectional study because a cohort is confounded with the development. However, in longitudinal study, cohort is external to a group of specific group of people that you're looking at, or namely, you're observing only one cohort. So even if cohort effect is actually present, you don't have a chance to observe that in longitudinal study. Therefore, cohort effect compromises or affects external validity of longitudinal study because you're observing only single cohort. It doesn't generalize to other kinds of cohort. Sequential method is a mixture of cross-sectional and longitudinal study. So you are going to observe the people who's at the different age group right now, and then you are going to follow them. Like 5-year-old, that's a 5-year cohort, and then you start observing 10-year-old, and then you start observing, and then you have 15-year-old, and you start observing, and then you're going to follow them for next 10 years. In this way, multiple cohorts are observed, and then the multiple cohorts are observed at different time in their lifespan, so that you can trace how different cohort group develop. That's the purpose of sequential method.